All right, our objective for today, I can solve and graph quadratic equations using intercepts and vertex. Read together, 1, 2, 3.
I can solve and graph quadratic equations using intercepts and vertex.
Okay, so which term is the only term that is new that you see on the objective?
Vertex.
Vertex. So underneath the where it says vertex, I want you to write here, right underneath, I want you to write vertex, highest, or lowest point. Vertex is highest or lowest point. Okay, you do need a Fourier model. Get a Fourier model started, please. Tell your neighbor the concept for today again.
I can solve and graph quadratic equations using intercepts.
Very good. That's the objective. Tell your neighbor the concept for today.
Quadratic equations.
So fill out your Fourier model for quadratic equations without looking at your notes. See if you got it by now. Definition, one example, one non-example. You got 2 minutes to fill it in. Once you're done, take a picture and send that in, or you can actually write on the screen if you want. I'll give you a couple minutes to fill that in. Ready, go. All right, it should look something like this. Did you get something like that?
No.
Okay, good. Underneath that, I want you to write steps. And since we're almost done with the third quarter by now, you should be able to come up with steps from me just presenting the process, yes? Okay, turn your paper over. In the back, copy example 1. Example 1. This is going to go really fast, so everybody go like this. Bear with me, please, because you know how we have multi-processes now for each problem? Well, today I'm going to add more. Yeah, we're going to have funner. Yay. All right, here we go. So it says, solve and graph using the vertex and intersects. So by now we understand what a vertex is. Is that correct? Yeah. All right. So, write your utensils down, look up to the screen. I'm going to go over the process. Stay focused so you can see the entire process, and then I'll have you copy each part. So I'm going to start with the first part. Here he goes. Let me zoom in. It says, solve and graph using the vertex and the intercepts. We already know what the intercepts are. Is that correct? Okay. So before I get started, step 1 in solving a quadratic equation, everyone should know. Yes? Tell your neighbor, step 1, please. That is correct. Standard form and making y equal to 0. So this is 0 equals x squared plus 4x minus 5. Okay, that's step 1. However, step 2, before I move on to solving and the rest of the stuff, I want you to do this part, but right now, just don't copy, just pay attention. For step 2, I'm going to call this step predictions. And you're just paying attention. So predictions that I can make out of straight from the equation given. So what is the first prediction? Well, the first thing that I know for sure is this. Tell your neighbor what that is, please. Everyone.
Constant.
It's our constant, but it's something specific. Our y-intercept. That is correct. Our y-intercept is -5. Okay. That's one thing. What else do I know from this equation? Well, the leading coefficient is a positive 1. And sometime back when I first introduced the graphing portion and I said how they looked, I said whenever the quadratic equation, and remember when we graphed them, I gave you guys a little sheet for you to graph all the different ones and look at the patterns. Well, if it's a positive coefficient, that means that the parabola, it's going to open up like this, or it's going to make a happy face because it's positive. So what do you think it's going to happen when it's a negative? It's a sad face because it's negative. So that's two things that I can predict from there. The other thing that I can predict is how many solutions I can get. Now, some of you are like, what do you mean, Mr. Q? Well, let me illustrate. You're just paying attention. So when we graphed our quadratic equations, check this out. Some look like this. Tell your neighbor how many solutions are there. 2, because there's 2 x-intercepts. Is that correct? All right. How about, sorry. Oh, my goodness. There it is. How many solutions there? 1, because it's barely touching the x-axis. However, didn't we get for some of the home place some that could not be factored or that cannot be solved? Well, guess what? Since this does not have x-intercepts, that's why you cannot solve some of the quadratic equations, because it's going to be graphed and it's going to be floating in one of the coordinates. One of the quadrants. So what are the possible solutions? 0 intercepts, 1 intercept, or 2 intercepts. Are we there? Okay, those are the possible solutions. So how can I tell how many solutions we get from a quadratic equation? Let me show you. So those are the two things we know. So we can use this. Do we know that already? The quadratic formula. Using some parts of the quadratic formula, we can find out how many roots. Now check this out. I'm going to use this part that's inside of the radical. This part is what we call the discriminant. And that tells us, when we simplify, how many roots we're going to get. So for example, before I do that, let's make sure that we understand what we're talking about. What is square root of 16? Everyone. No, it's not 4. Square root of 16 plus minus 4. So if these were to be roots, how many roots do we have? 2, a positive and a, okay. What is square root of negative 16? Is there such a thing? No, so then how many roots do you think there are? 0 roots. What is square root of 0? 0. So that's how many numbers? 1. So how many roots? 1 root. Because the answer is 0. You ever understand? This one, it's not 0, it's none. Because there's no such thing as negative square root of 16. So with that said, now let's use this part. Here we go. I'm going to use b squared minus 4ac. Now I'm going to substitute values. What is b here in my equation? 4 squared minus 4 times, what is a? 1, and what is c? Negative 5. So let's see. This is 16. Negative 4 times 1 is negative 4 times negative 5. That's positive 20. What is 16 plus 20? 36. Since this is inside of the radical, it's a positive number. Guess how many roots I'm going to get? 2. So therefore, how can we use the discriminant to tell how many roots? Well, if we get a positive number, then it's 2 roots. If we get a negative number, it's how many roots? None. And if we get a 0, how many? 1 root. And that's how we can use the discriminant. So copy that part of the prediction. We're just predicting right now how many roots we're going to get. Copy that, please. So really quick, so far in the process for today's lesson, I've done 2 steps so far. Step number 1 is checking for standard form, making sure that y is equal to 0, yes? And the second step was just predictions. What were the predictions that we got from the equation? We know the y-intercept is -5, and that the parabola is going to open up because it's a positive leading coefficient. Are we there? What else could we predict? Using the quadratic formula, we use the discriminant, which is what's inside of the radical, to see if we're going to get either 2 roots, no roots, or 1 root. And we found out if it's a positive number, we get how many roots? 2. So for this one, we're going to get 2 roots. So can you picture now what it's going to look like? Yeah, it's going to open up. It's going to have the y-intercept at -5, okay? And it's going to have 2 x-intercepts. So far, so good? All right. So with that said, let me zoom out a little bit. So let's see where we're at so far in regards to what the problem is at hand. It says solve and graph using the vertex and intercept. So I made predictions. So now let's figure out the vertex. And what did we say the vertex was? The highest or lowest point. So I'm going to write over here vertex, highest or lowest point. So for a point, what do we need, everyone? What values do we need for a point? 2 values. What values? An x and a y. So you open up a point, and we need an x value and a y value. So writing utensils down, look up. I'm going to show you how to find the x value of the lowest or highest point of the parabola. Pay attention, please. Here it goes. Now, I'm going to use, again, the quadratic formula, but now I'm going to use a different part. Look up. I'm going to use this part. We call it the California part. There it is. You guys see the California?
Yeah.
Okay. And check this out. Basically, I'm only going to use x equals minus b over 2a. You guys see it now? X equals minus b over 2a. But that's only going to give me which value? X. So let's see what x is. Minus, what is b? 4 over 2 times a. What is a? 1. So therefore this is negative 4 over 2, which is negative 2. That's my x value. All right. However, I need a what? Oh, not a y-intercept. A what? A y value. So look at here on the screen. Look all the way around the screen. Tell your neighbor what I need to do to find my y value. Some of you already saw it, right? Okay, who can elaborate? Go ahead, Roman Carlos. What do I need to do with that value of x? That is correct. Substitute in the original equation to find my y value. So I write my y equals, but instead of writing x squared plus 4x minus 5, what do I write? Parentheses, negative 2 squared plus 4 times negative 2 minus 5. So this is 4 minus 8 minus 5. What is negative 8 and negative 5? Negative 13 minus 4 is negative 9. And that's how I get my vertex. So if it's opening up, that means the lowest point is going to be at what point? Negative 2, negative 9. Everybody there? Copy that. And of course, this is what we're going to call step 3. So what would you call step 3? Tell your neighbor what would you call step 3. Identify the vertex. That is correct. And step 4, for those of you that are already almost done copying, step 4, I want you to solve. Do you know how to solve this equation? Does everybody know how to solve that equation? Yes. Tell your neighbor which method you're going to use to solve this equation. Factoring, okay. Kelsey's going to use factoring. Alexander, which method are you going to use? You want to use completing the square? Okay. He's going to use completing the square. I guess he likes to do more work. Paulina, which method are you using? She's all using the quadratic formula. Yeah, let's go. Which method would you use? Also, bad. Hands if you're going to use factoring for the solving. Yeah, that's the simplest method, right? Power Rangers, da, 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 da. What goes on top? -5. What goes on the bottom? 4. Factors of -5 added up to 4. -1 and -1 and 5? Oh, my bad. And 5. All right, so I'm going to rewrite this. 0 equals x squared minus 1x plus 5x minus 5. And we know what to do from there, yes? Group. What's GCF for these two? X minus 1 plus, what's GCF for these two? 5, x minus 1 equal to 0. What are my factors then? X minus 1, x plus 5. And from there we do ZPP, yes? So what does that mean? Right, both of them equal to what? 0. X minus 1 equals 0, and x plus 5 equals 0. Let's solve. Plus 1, x equals 1, minus 5, x equals -5. These are my solutions. X-intercepts, zeros, and roots. Okay, so it says solve. Did we solve? Yes. Did we get the vertex? Yes. Do we know the intercepts? Yes. Can we graph now? Yes. All right. Get a graph paper in front of you. Here, let's see. Only this row. Get for this row, Roman and Jerry. Get for your row. And then once you have yours, split it and share with the person to your left. Hurry up, hurry up, hurry up. Okay, let's graph this. Hurry up, guys. My goodness. Oh, there's some over there. Sure. Okay, while they get you the graph paper, what were my roots? -5 and +1. Okay. What is my y-intercept? -5. What is my vertex? Yeah, to your left. What is my vertex? -2, -9, which is right there. Now I can graph my parabola using those points. So I start from left to right. Now we know that the lowest point is this one. At that point, we come back up. Bless you. Bless you. Bless you. Bless you. There it is. Okay? Yeah? The roots, here they are, the y-intercept, and the vertex, yes? Okay? Now, look also what happens with the vertex. If I was to draw a straight line down through the vertex, look up, please. Look up. If I was to draw a line straight down through the vertex, this line that is an imaginary line going through the vertex called the Axis of Symmetry. And why is it called Axis of Symmetry? Symmetry means that it's equal and balanced. So watch. Look at the root. How many steps is the root away from this axis? This one. 1, 2, 3. Very good. So guess what? The other root should be how many steps? 1, 2, 3. That is correct. Therefore, look at the y-intercept. How many steps is the y-intercept away from that axis? 2. 1, 2. So therefore, since this is of symmetry, there has to be a point how many steps away to the other side? 2. 1, 2. What is this point? -4, -5. Does everybody see that? And now we can actually make a parabola that's a little bit more symmetrical from one side to the other. So for today's home plate, check this out. I want to see you do steps 1, 2, 3, and 4. And of course, 4 includes the graphing, yes? All right, so for tonight's home plate is on page 617. Only do the odds, please. And I want it like this, in this way. Okay?
617?
617. Make sure you write your steps in your Cornell notes. Have a good one, guys. To your home plate. There is tutoring. If I don't see you, see you guys tomorrow. Bye.